My name is Ashraful Alam. I'm a postdoc at Aalto University, Finland, at Department of Bioproduct and Biosystem. I have a forestry background, and I have been working before with LCA in forestry production system, forest management, and climate change mitigation issue. And now I am working on this project and assessing sustainability impact assessment. So you can see the in the picture, there are two buildings. I'm going to talk about them. The one in the right is cement based building, and the one on the left is wood based building. So basically they are located in the same area, adjacent to each other. So Finnish case study. So this is the wooden part of the building. Those buildings were or this wooden building were completed in 2 years ago, and it has 4 story and with 58 apartment unit. And for cement part, it has 60 apartment unit. For wooden building, the wood or timber was used, light frame wall with and floor with wooden staircases and balconies. I'll talk detail of them later. And one important thing is that all the wood is sourced from Finland, so there is no importation from outside. Here you can see this floor plan, and this is half of it. And basically they had three building, A, B, and C. This is the part with B. And in our analysis, we have done analysis for B and C part. And the B and C is like mirror one to another. And you can see the wall, and this is the staircases, the balconies, corridor, and few rooms. And the total gross floor area for this B and C apartment is 2000, about 2,800 square meter. And now you can see the wood component that was used. It's about 370 cubic meter, of course, from Finnish forest. And the sawn part is about 180 cubic meter, mostly used in wall, cross laminated timber, mostly used in balcony, and it's about 40 cubic meter. And then we have laminated veneer lumber, which is about 160 cubic meter and used for floor. Here you can see that the system boundary that we have adopted, it's pretty much same like Swedish case, but we haven't included this prefab uh, mm, factory. This, but we have included the distance from this road transportation, but not the what is happening inside prefab factory. Other than that, this is A1 is raw material supply, then A2 is transport of this raw material to uh, sawmill or manufacturing plant, and then transport to building site. Here you can see the sustainability impact that we have assessed. For environmental indicator, it is same like Swedish case, this GHG emission, but we have included energy use and carbon stock here. And then for economic indicator, gross value added, production cost is same like Sweden. And then for social indicator, employment and occupational safety, so we use accident as uh, 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 for this, and then we have wages and salaries. And these indicators, it is same like all of these cases. So it was based on stakeholders feedback. and then the data for those indicators are collected from companies by interview or sending questionnaire through EPD, literature studies, and in some cases estimation. And all this data in our results are calculated or shown in per square meter of gross floor area. Now we come to this wood supply chain. I think we have pretty much a straightforward supply chain compared to Sweden. Forests are harvested with this big machine, and then wood is transported from forest to roadside forwarding, and then from there, this big truck is transporting them to sawmill or other mill if needed for final product, and then finally ending up to this construction site. For this road transportation, usually they use 40-ton truck load size, but for final product, it's 25-ton load size. Here, you can see the supply chain that we have got from TOSIA. We have used TOSIA tool for sustainability impact assessment. I guess in Swedish case, you have already heard about it. And you can see these three element supply chain: sawwood, CLT, and LVL. For sawwood, so there is this forest, and then harvesting, and then forwarding to roadside, truck to sawmill, and then sawwood production, and then transport to the construction site. And beside that, this A1, A2, you can see these stages, life cycle stages. So these two are for A1, and then truck to sawmill is 2, A2, and then production is A3, and then transportation is A4. The similar supply chain is also for CLT, but for CLT from sawmill, it goes to the CLT factory, and then CLT production and transport to the construction site. And for LVL is also similar to sawwood, but it doesn't go to sawmill. There is LVL mill, so it goes to LVL mill, and from there, passing through this production process, it goes to the construction site. And we have collected for all the indicators for each of these processes. So for harvesting process, for transportation, for production, and then for transportation. And just to remind you what was the amount of wood was used, it was 370 cubic meter, and you can see the different fraction for different component. So here the concrete chain. So concrete. So these are the raw materials: cement, steel, and concrete. As in the Swedish case, you have heard the steel is not that much, but cement or lime, those are the major raw material. So those raw materials are used to produce this wall, floor, these prefab elements, and then finally ending up to this construction site. And those in TOSIA, the supply chain look like this. It is pretty much same like Sweden. We have this A1, A2, A3, and A4, 4 different stages, and for 4 different concrete elements. And for concrete part, the amount was totaled about 900 cubic meter. And the gross floor area here was a little bit less than timber. It is 2,754 square meter, and external wall is mainly sandwich panel, about 160 cubic meter. Then solid panel is internal wall, balcony wall and slab. It's about 380. And then hollow core slab for floor is 360 cubic meter. Now coming to the result. So in the left side, you can see this greenhouse gas emission. This is environmental indicator. And I think the result is pretty much again same. It's like Swedish case. The timber emit 3 times less carbon emission than concrete. And the most part is goes to this about 70% in A1 stage. And for concrete, it's 85%. And in the right side, you can see the carbon stock. So there is no stock for concrete, but for timber, what we calculated, we found is about 100 kilogram of carbon dioxide per square meter. Carbon is stored, and if we deduct this value from here, we can find about 70 kilogram of carbon per square meter is carbon balance for these buildings. This is also environmental indicator. It's energy per square meter. Again, energy is lower than concrete, which you can see in the left figure. And in the right figure, you can see the share of renewable and non-renewable. And in concrete, for concrete, mostly used non-renewable. But for timber apartment, it was 60% that was used non-renewable. Others are renewable. Now I come to this economic part. So I'm not going to show or is because we are not complete with this economic value for this concrete part, but we are still working on it. And you can see the value for timber, and the gross value added is about 60 euro per square meter, and production cost for timber little bit over 40 euro per square meter. And for social part, in the left side, you can see wages and salaries. It's about €2.5 per square meter for these 4 stages. So we need to be careful when we look at the figure. But for employment, we didn't find any major differences. But the main accidents are for timber part happening in A1 stage. This is a little bit different than Swedish case, in which they found this in A3 stage. But for concrete part, it's mainly in A3 stage. And when I was collecting those data, I found that 10 years ago, the situation were really completely different. So this value could be 10 times more, actually. So now it's reducing largely. And about accident, so we got no fatal accident in both cases, but for non-fatal cases, the concrete was higher than timber. Now I want to summarize here what we got. So these are four different stages, and we have wood and concrete. And green means lower, and red means higher compared to concrete. As you can see in all these parts, this mostly green. But here I did some analysis, and I found the value could be different than what we see in the EPD. This is mostly because this EPD don't use or add this renewable energy. So here I have added all of them and I got quite big number. But in this A1 or sorry, A2 or A4 cases, that was modified according to our study. So the distance were uh, changed according to what was happened for those buildings. So basically, all this we found is green, but for this employment, we found that a little bit higher, or sometimes a lot compared to concrete, and that may lead to if there is higher employment per square meter, that means higher cost, and that is also we see in the literature that wooden buildings are expensive. But it would be interesting to see how, if we calculate this for concrete, how it looked like, because we have focused on structural element. So that and this when they say expensive, that could be something like for this fire. So they could use this sprinkle system. So that is expensive. That could be one reason. So that is what I wanted to say. So if you have any question,